So here's our first question. At a school, the ratio to teachers to students should be at least 3:10. Keyword, at least. If there are 7 teachers on duty on Mondays, what is the maximum number of students that the school can have? Great. So to solve this question, first we'll start with the ratio that's given to us, right? So we are told that the ratio of teachers to students should be at least. It means it's either equal to or greater than the ratio given. It is at least that value. It cannot be less than that value. So since we can write a ratio also as a fraction for ease of calculation, let's do that. But remember that the intent of a fraction in a ratio is different. Great. Keeping that in mind, let's go ahead. So if you use this and plug the next piece of information in where we say that we have 7 teachers on Mondays, so we would get, plugging 7 over here, we would get 7 over s is greater than or equal to 3 over 10, right? So if you cross multiplying, what do you get? You get 70 over s is greater than or equal to 3, right? And if you go further, you will say 70 over 3 is greater than or equal to s. Or in the reverse, you could also say s is less than or equal to 70 over 3. It's the same thing, right? In this way, s is less than 70 over 3. So don't forget to change the symbol when you're trying to replace this that way. Because s is less than 70. Even if you put the s over there, it's not going to be greater, right? So that's how that works. So if you solve this, you would say, what is 70 over 3? 69 is 3 times 23, right? So you could also say 3 to 6 and 1 carried and 3 and then so on, right? So you would say s is less than or equal to 23.333 to the infinity. Great. So what is the question asking us? The question is asking us, what is the maximum number of students that this school can have? Maximum number. So s has to be less than 23.3. So what is the maximum number that you could have? It can't be 23.3 because students need to be in a whole number. So the maximum integer that's less than 23.3 is 23, right? So if you go and check back the options, you would have 23, which is option D. That's your answer. Great. Let's go to the next question. Great. So let's start with question number 2. X is to y is 4 is to 13, a is to b is 12 is to 17, k is 12 is 19 is to 20. What is the value of x plus b? Can we find the value of x plus b with just this information? No way. We have absolutely no clue what the value of any of these numbers or any of these variables are, right? No clue. But we're also given 2 other pieces of information, another couple of more ratios. So our objective here, which is most likely not going to be useful, right? Because just with a bunch of ratios, can you find any of these numbers? Most likely not. But the idea of these questions is not to find the actual answer. As you can see from the options, there's no answer given, but rather it tells you things like statement 1 alone is sufficient, but statement 2 alone is not sufficient. So these kind of questions are known as data sufficiency questions. Data sufficiency questions. These kind of questions are testing whether you understand if the data is enough for you to find the answer rather than be able to find the actual answer. So if you see the statements, you will say statement 1 alone is sufficient, but statement 2 alone is not sufficient. This is telling you that if you just had this extra piece of information, you'll be able to find the answer. Or it says each statement alone is sufficient, which means any of these 2 separately, if used along with this information, would be enough for you to find the answer. So let's see what is true. And one other thing which we covered in our concept video is that when you have a bunch of ratios given to you, it's always best to start with an assumption of a ratio. Start with an assumption of a factor, which when multiplied by each of these numbers will give you a particular starting point to calculate. So let's assume that the ratio number here is P. Another, let's say it's Q, and let's say here it's R. So when you do that, you know that when x is to y is told to be 4 is to 13, you can assume that it's the common ratio is P. When you do that, you know it's the same as this because you can just cancel out p. But when you write it this way, you get the option to be able to say equality, where you can say x is equal to this and y is equal to this. But you could not do that here because you don't know if x is equal to 4. It is in the ratio of 4:13 with y, which means if it's multiplied by any number, y also gets multiplied by the same number. So we don't know that what that particular number is. It could be 1, 2, whatever in between. So now we can say x equals 4p and y equals 13p. Right, so similarly, a would be 12q, b would be 17q, k would be 19r, and L would be 20r. Right? So these are our 6 values. Let's say if the first piece of information is of any use to us. So they are saying x to L is 1:5. So let's try it as a fraction for ease of calculation. So x by L is 1/5. But we also know that x is equal to 4p, right? So x is 4p and we know that L is 20r. So 20r. So this is 1/5 and this gets cancelled. This means p equals r. Great. Interesting piece of information we have. P equals r. P equals r. This is the first piece of information. So let's try the next one. So the next one tells us that a is to k is 12:19, right? A is to k is 12:19. Means a by k is 12/19 and a is 12q and k is 19r. You probably know where this is going, right? 12q/19r. So this gets cancelled out and we also get q equals r. So p equals r, q equals r. What does that mean? It means p equals q equals r. Great. But does any of this help us answer the question? So we had p equals r, right? But it didn't tell us. If you know p equals r, would you be able to calculate x and b? No, you just say that k is equal to 19p and L is equal to 20p, and you would say x is 4p and y is 13p. That's it. So statement 1 alone is not sufficient for you to answer the question. It's not sufficient. If statement 2 alone is sufficient, if you know q equals r, still the same fate, right? No. Are they together sufficient? So if you say p equals q equals r, we get a equals 12r or 12p or whatever, and all of them are equal to something, but we don't exactly know what they are, right? We need more equations for us to find the actual answer. So nothing is going to help us find x plus b. Nothing is going to help us find x plus b. What is x plus b? We don't know. We only have these two pieces of information. Since we cannot find the actual values of x and b from the given information sources, we cannot find the answer. So which means statement 1 and 2 together are not sufficient. Option E is the answer. Let's go to question number 3. Looks like a simple question, doesn't it? A fruit bowl contains oranges and bananas in the ratio of 7:5. Okay. Which of the following could be the total number of oranges and bananas in the fruit bowl? Okay, so we have oranges to bananas in the ratio of 7:5. Or for simplicity's sake, which I like to do, is to write it as a fraction. It's not technically wrong, but they are not the same. Remember that. And so it says which of the following could be the total number of oranges. So how do you find the total number here? Is O equals 7? No. Is B equals 5? No. So we need a factor which makes this possible that we will be able to equate these values to these numbers. So when you put a factor, see, the idea here is that O could be 7 times something and B would be 5 times the exact same thing. These two numbers have to be the same, but we don't know exactly what the multiplication of those numbers is. It could be 1, it could be 1.5, it could be 2.776. We don't know exactly what that number is. Right? So in this case, it's probably not 2.776 because it's an orange, but P is probably a whole number. It's like a natural number. But we don't know exactly what that natural number is. So even if we don't know it, our idea is not to find the exact value. We just need to find what could be. Right? So when O is 7p, B is 5p. We don't know exactly how much that is, but we know that we can say O plus P would be 7p plus 5p, right, which is 12p, right? So if you take this piece of information back, so we have inferred that the total could be 12 times some number, we don't know what that number is. And look at the options. So could be 24? Yes. If p can be 2, we don't know, but it can be. It could be 24. So 12 times 2 is 24, right? So it's possible. Can it be 44? Yeah, but since it's an orange and a banana, we want the number to be a whole number, right? So we can't have fractional values of total numbers. So for it to be 44, p would have to be a fractional value. If p is a fractional value, that means 7p would be a fractional value and 5p would also be a fractional value, which can't happen in this case. Can it be 60? Yes. If p is 5, then 12 into p would be 60. And in that case, you have 35 oranges and you have 25 bananas. It's quite possible. So options 1 and 3 are both possible. 1 and 3 only. So option D is your answer. Okay, let's look at question number 4 now. The question says, a number x, when increased by 20%, yields the same results as another number y when decreased by 50%. Right, so that's pretty clear. If the difference between x and y is 140, what is the sum of x and y? Great. So the first thing I would like you to understand is how do you easily say increase by 20%? So do you know that? If you don't, then see 20% is nothing but 20 by 100, right? So that's how we write it 20%. So what is x, 20% of x? So we need to find 20% of x. 20% of x. This is nothing but 20 by 100 into x, which is equal to, what is it? It's 0.2x, right? So that means when anything increases by 20%, it increases by 0.2 times, right? So when you say x increased by 20%, you need to say x plus 20% of x. What is that? That's 0.2x, right? So whenever you think of a 20% increase, always divide that number by 100 and add that quantity to the actual number, actual initial quantity, right? So anything increasing by any percent is equal to that number plus percent by 100 into that number. That's always the case, right? So this is going to be 1.2x. This is increase of 20%, right? And what is decrease of 50%? So 50 by 100, 0.5. So anything decreasing by 50% will reduce by 0.5. So that means by minus 0.5 by, right? You're getting that, right? So 0.5 by, when you decrease something 50%, it's going to be half of that. It's pretty obvious, right? That's how we get to that number for any percentage value. So now what this question is telling us is this number will increase by 20% is the same, yields the same results as another number y decreased by 50%. So that means this and this are equal, right? So that means 1.2x is equal to 0.5 y. Now we're also told the difference between x and y is 140. So now the problem is subtraction is always a point of what is higher, right? So this number is positive, right? 140 is a positive number. That means if you write it this way, x is higher than x is bigger than y. That's the only way it can work. But if 1.2x equals 0.5 of y, so the number x when increased is equal to just half of y, which basically tells us that y is greater, right? So this is wrong. You can't do this. If you do this, you get the wrong answer. So what you have to say is y minus x is equal to 140, right? So now we have equation 1, we have equation 2. They are called simultaneous equations, and we solve them. We get to answer the two variables, right? So let's do that. Great. So first equation is this, second equation is this. So what I'm going to do here is make sure that I'm going to multiply this by 0.5x so that I can cancel these two out, right? So I'm going to write 0.5y minus 1.2x equals 0. I'm going to bring this over here and do that. And if you take this equation, so if you multiply this by 0.5, you get 0.5y minus 0.5x equals 0.5 times 140. That means half of 140, which is 70, right? So to solve this, what do you do? You try to remove these, so to cancel those out. So you change this symbol cancel these out. So 1 minus 1.2 plus 0.5 will be minus 0.7, right? This gives you minus 70. So what is 70 by 0.7? 100, right? Not 10. So x is equal to 100. So what is y? We know y minus x is 140. So that means y is equal to x plus 140, right? So this is 240. Right, x is 100, y is 240. So let's go back. Now we need to find the sum of x and y. So we got x is 100 and y is 140, right? So the sum would be 240, which is option B. Right, so if you want to cross check your answer, it's very simple, right? So difference between x and y is 140. So, oh sorry, I made a mistake. So the mistake is y is 240, right? So it's not the sum of x and y, right? So that means this is 240, this is 340. See, we already had the wrong option. That's sad. So the answer is 340 and not 240. Great. So I found that because I tried to check the answer where if the difference between x and y is 140, y cannot be 140, right? So obviously. And you get the difference is 140, and if you 20% of 100 increase will give you 120, half of 240 is 120, that works, right? So that's great. Let's move to the next question. Okay, let's look at question number 5 now. The ages of a father and a son are in the ratio of 13:7. Father and a son, okay. After how many years will the son be as old as his father now? Okay, one thing to notice is this is the data sufficiency question, right? Data sufficiency, DS, that we'll be talking about. So the thing about these questions is you need to tell if the data is sufficient for you to be able to answer the question and not actually find the answer. You don't need to do that. But even if you did, it wouldn't hurt. So let's see if the data is sufficient. So ages of a father and a son. So let's say F to S are in the ratio of 13:7, right? So what do we do first? We assume that there's a common ratio which is P, and we say the age of the father is 13P, and we say the age of the son is 7P. Done. Okay, so after how many years will the son be as old as his father is right now? So that means we need to figure out, see, 7P is the current age of the son, 13P is the current age of the father. After how many years will 7P become equal to 13P? That's all basically it's saying, right? So 7P plus some number x is equal to 13P. That's all we need to find. What is this number x? Is what we need to find. Great. So to do that, do we have any more information? The first piece, the difference between their ages is a natural number that lies between 10 and 20. Okay. So the difference between these two ages, so that means, so 13P minus 7P is between 10 and 20, which means it is greater than 10 and less than 20. So let's make this to make it clearer. So this means 10 is less than 6P is less than 20. So this number is a multiple of 6. So how many multiples of 6 do we have between 10 and 20? We have 2, right? So which is 12 or 18. So we have two options here. So we can't really say, so either P could be 2. So if we take 12 as the option, then we'd say P equals 2. If you take 18, then P would be 3. But we don't know exactly what it is. And if we know either P is 2 or 3, we'll be able to find X. So we just need to say 6P, right? So X is equal to 6P basically. But we don't know that. So one statement alone is not sufficient for us to answer the question. So what about second statement? 3 years ago, the father's age was twice that of his son. Okay, let's try that. 3 years ago, the father's age. So that means 13P minus 3 is equal to 2 times that of 7P minus 3, right? 3 years ago. So what is 3 years ago son's age? It was 7P minus 3. What's father's age? 13P minus 3. So that was double of this number. So what does this give us? So this gives us 13P minus 3 equals 14P minus 6. So this means if you take this that side, that's minus 13 and plus 6, right? So P equals 3. Hope you got that. So from this statement, we did get P is exactly equal to 3. So statement 2 alone was sufficient for us. We didn't even need the first statement, right? So if P equals 3, what is X equal to? So if P equals 3, X equals 60, right? So x is equal to 80. But that doesn't matter. What matters is statement 2 alone is sufficient for us. We don't even need the statement first. So the answer is option B.